Hi guys, welcome back. So in this week's module, we're going to talk about kinship and dominance. Kinship is sort of one of our benchmark theories. So it's going to sort of cut through everything we talk about moving forward, the concept of kinship and kin selection. So I'm going to start with that. And it's a little bit of a nebulous topic, meaning it's very broad. I'm going to try to boil it down a little bit so that you guys can kind of understand it and understand how we're going to apply it in this course. So if we go back to our last lecture and we talk about that concept of fitness, right? Do we remember that fitness has nothing to do, in this case, your inclusive fitness has nothing to do with your physical characteristics. It all well, yes and no. But what it really boils down to is your ability to pass on your genes. So yes, your physical fitness does play a role in that. But again, what we're meaning in terms of fitness is not going to the gym and exercising. We're meaning genetic fitness. So my goal as an animal is to spread my genes as much as possible. So I'm going to have different social grouping strategies, different mating strategies, different dominance hierarchy styles. All of those things are going to play a role with my ecology to make sure that I'm able to be as efficient as I can be and as prolific as I can be in spreading my genes. So what does that look like? So your inclusive fitness is inclusive of all your genetic material. So the most beneficial way for me to spread my genes is to procreate. Whether I'm a male or female, whatever offspring I have will have 50% of my DNA. That makes sense, right? So mom is giving half of the ingredients, dad is giving half of the ingredients. That DNA with that offspring is 50% yours. So to be the most fit, my idea would be to breed as much as possible and to have as many offspring survive to adulthood, right? So why do I need them to survive to adulthood? If my goal is to just spread my DNA, well, because if they're able to survive to adulthood, they can then breed, and those offspring of your children will share a percentage of your DNA. Okay, so we want as much of our kin, our family, to reproduce as well. So we want our offspring to provide grandchildren. We also do want to help support our other relatives. So a sister, brother, mother, father, okay, depending on our social structure, by supporting their ability to spread their genes, a portion of our genes continue to spread. So again, this all plays a role in how our animals deal with their ecological settings, how they then group socially, right? Because we do have some solitary animals who don't pair up, so they really don't know what's happening down the road with their mothers, brothers, sisters, grandchildren, right? But the odds are in their favor that down the line their genes will continue to spread. In other animals where there might be more competition, it makes sense to group, right? To ensure the safety of those relatives. Because again, kinship is important in your inclusive fitness. Okay? So again, our inclusive fitness is our genetic fitness. It's our ability to be as prolific as we can be with our genes, to spread them as much as possible. So it behooves us to support our kin. Okay? So if we're looking at primate societies, kinship is really important. Dominance lines fall in kinship, right, by relatedness. Your rank in the troop is directly related to your kin, okay? When it comes to competition, right, we will support our kin in a fight more likely than we will be to support non-kin or non-relatives. This all makes sense, right? When it comes to additional support, when it comes to we're going to talk about alloparenting and giving support to infants. We're more likely to give that support to an infant that is related to us than one that is not related to us. So overall, we're going to select to support individuals related to us before we support those that are not related to us, okay? And that's not a hard concept, I don't think. I think in general, we kind of understand what that means. So how do animals recognize who's related to them? So there's a lot of different studies that have happened about how animals recognize individuals that are related to them. Some studies are trying to prove that it's innate, meaning that it's ingrained in us genetically to recognize others of similar genetics. That hasn't really been proven to be true. There's some anecdotal evidence that that might be the case, but I'm going to give you guys an example of a study. They would have, oh gosh, and I can't remember what kind of animal it was, but they were pups. I think it was squirrels, squirrel pups. If you guys look that up and it's wrong, don't don't call me out on it. But we'll use squirrels as the example because I think it's a good example. Squirrel pups. Two mothers, completely unrelated, had a litter of squirrel pups. They would take some of the pups from group A, some of the pups from group B, put them together in this group, and again, do that over here. So they would split them into groups, okay? So let's say, you know what, let me just grab a piece of paper. Okay, this will be, so we have group one. I'm sorry, I wrote this on the back side of another drawing. So group one would have two pups from group A and two pups from group B, or mom B, and group two would have the similar, okay? So when these pups are all raised together, they're not genetically related to each other, okay? But they were shown to support each other, okay? If we then take all of the A's out and put them with A's and all of the B's out and put them with B's, they don't recognize the other animal from the other group, even though it's their genetic sibling. Okay, so I hope that makes sense. So again, we have, say, 4 pups in each litter. We're going to split them evenly, so there's 2 A's and 2 B's in each group. These animals act as if they're a normal family, right? Because that's all they know, right? They grew up in proximity to each other, okay? Down the road, if we take them and regroup them into their genetic groups, they don't recognize those other individuals as their kin because they didn't grow up with them. So that kind of pokes holes in the theory that there's some sort of like innate genetic indicator that we can recognize those that are related to us. It really has to do with proximity. So what we're going to talk about in a lot of these things moving forward is that a lot of these behaviors happen because you are in close proximity to your relatives, okay? You grow up around them, you spend your day near them, so you're going to give beneficial care or assistance to those you've spent your entire life in close proximity to, okay? And I would say, did your mom and dad have like a best friend and you grew up with their kids and they weren't your relatives, but you may have called them your aunt and uncle, right? And you may be closer to them than you are some of your cousins. So that's where this is coming from. Like if you're in close proximity, the assumption is that you are kin in animals. Obviously, it gets a little trickier in humans, but they are able to recognize their kin because they just spend so much time in close physical proximity to those individuals throughout their lifetime. Okay, so that's kinship. It's sort of a very, like I said, very broad-reaching concept, but we'll see it play out consistently throughout the course. So if in future modules I talk about kinship and you're a little bit confused, it never hurts to pop back to this video, okay? And just give it a really quick review because kinship is important for our genetic or inclusive fitness. All right, guys, I'll see you in the next video, which is about dominance.